Hello, everyone. Welcome to the second instance of Pedro's Pitstop. This podcast series is all about looking into Formula E and how it connects with the work that we do at Vestas. And then today, I think I'm thrilled to have a really interesting chat ahead of us with Bodo from the Formula E Mercedes EQ Formula E team. And you're a strategist, right, Alex?
That's correct. Yeah, I'm a strategist with the team, which means I collect data, information, and try to get something useful out of it to eventually make, hopefully, the best calls for the team.
We'll certainly tap a lot into that, as I think it's one of the most interesting roles that sits in a racing team. And also, I'm really happy to have Thomas here today, who's a meteorologist. And Thomas, maybe you can put a word to what that means for us investors.
I've been working as a meteorologist in Vestas for the last 10 years, and I'm working as a product owner for a little meteorology group that has to do with everything that's related to meteorology and climatology, and where we can we work with where we can add value to the organization. So that's anything from lightning alarm systems to advanced weather forecasting with high resolution modeling. And so we are helping the service business, the construction business, and so forth.
What is it? What is the role of a strategist in a Formula E team? And how do you connect with all these elements of data that you mentioned before?
So my role is actually challenging, unique. It's a pleasure. It's thrilling because I'm allowed to actually work in one of the most competitive racing series on this world. And it's most competitive because you meet and you compete against actually the best engineers available on this planet, and you compete on unique street circuits. So if you look on different racing series, in our racing series, they normally race the same circuits each year in and year out. So they collect a lot of data and they can use a lot of historical data. In our world, actually, the track changes every time. So every time we go to a circuit, we have to assess, we have to evaluate data, we have to generate data, we have to collect data, and we have to go through a lot of homework to actually prepare for a race weekend and eventually execute. So my job is actually looking across all the different sources available, collecting all data and information available, filtering the information, combining the data logically to then eventually create a good basis for decision making.
And then I assume that serves both for the car setup ahead of the weekend and during the practice sessions, but then also during the race, right? You tap into that data.
Yeah, this includes every aspect. It includes car setup, calibration, software simulation. We have experts in every corner and for each area effectively. I'm interested in the crucial factors, the KPIs, the points where we can make a difference over the weekend. So we have a bunch of actually really good engineers. Everybody takes care of his specific field, and you name it. Car setup is a field. We said simulation is a field, software is a field. So literally everything. I will pull the information and I will make sure they meet somewhere sensible and then make the calls.
Often, and then also linking with the conversation we had with Nick, right? Often it's not so much about the data that you have. It's around how you distill it, simplify it, and then communicate it in a way that it's meaningful. I'm sure you'll agree with this, but how do you tackle this challenge? Do you have any kind of reflections on it?
Yeah, so because you're living in a digital virtual world with a lot of data and it's masses of data, it is fairly complex. So the challenge is actually to trim it down and to make it a useful set of data. Yeah, you filter out the important bits, you connect the important information, and then you create KPIs. And as in normal life, as in normal industries, you make decisions based on KPIs and simple information, because everything else is just too complex to digest and to actually make a call. I would go as far and say racing and Formula E in particular actually magnifies the challenges of the industry.
You know, in terms of this data collection, of course, and meteorology being huge amounts of data, how does this connect with our partnership with Vestas and the Mercedes EQ Formula E team?
Yeah.
How do you tap into that?
Yeah, as I just mentioned, it's probably the most challenging racing series in the world. everybody is doing a good job. So you're looking actually for the bits of competitive advantage that other teams and other engineers don't have access to. And through our partnership, we identified actually high quality weather information, and access to a massive database is a competitive advantage. So when we go racing, it is not only about the setup, but actually about battery management and car management. And one important factor of battery and car management is the temperature of different items of the car. This is tire temperatures, and this is battery temperature. At some point, the battery will just derate or stop working when it overheats. And obviously, the information of temperature around the circuit on different levels is a massive factor in terms of doing the calculations and actually preparing for the race. When you can exploit the competitive edge of your car setup, and this includes the battery setup and calibration, you can gain lap time. If you don't have good information, obviously you take it more conservative, and you just take off a chunk of lap time and a chunk of performance from your car. So that's why for us it's a competitive advantage.
And then Thomas, how is it for you coming from a world of sighting and defining turbulence at hub heights to feeding this kind of information to a Formula E team?
Well, it's obviously very interesting and also challenging to try to see where we can contribute with all the knowledge and the numerical weather prediction models that we have in-house and that we're running all the time to support the organization, to help the team, gain that little bit of an advantage by using the data. So, for example, just today I spun up the model for Rome, and we're doing actually two different weather models for Rome. So we have also have an idea how to assess the uncertainty between the different weather models. One is initialized by the American global data set. The other one's initialized by the European Center global data set. And then we downscale it, so we have in very high detail what's going on, every 15 minutes on the track. And hopefully that is then what can help the team make a right decision. And this is, we already use this weather model for other things. It's used in the field, like weather forecasting wise, and it's also integrated into a lot of our new technology, like hybrid plants. So it's very interesting to just take one of the little pieces from the whole portfolio we have of what we're doing in my department and try to see if it matches and can contribute it to the team. And so far we've been lucky with that, it seems.
It's the first time we do something like this at Vestas and collaborating externally.
Well, actually, I've been so fortunate to also help the Volvo Ocean Race team in 14 and 15. That was a bit in the background from the home office. And then in 17, 18, we provided a ton of data to the Volvo Ocean Race team. And I even joined the shore crew in various locations around the world where we ran these high resolution models. We ran CFD over the harbors for the starting point. So we've been doing this before and trying to contribute with whatever we had on the shelf already, tweaking and tuning it a bit so we could support the team. And in that case, I was like for offshore racing. And we even also supported some of the rowers, like rowing across the Atlantic Ocean, mostly for service, for safety purposes.
In racing, you often go as lo-fi as having spotters on track, right on the other side of the track to see if it's raining. So the granularity is minutes and meters in terms of how relevant rain or temperature can be, as you mentioned, Alex, in a race. And Thomas, I guess, how deep can we go in terms of granularity? Is it in terms of time and kind of
I think the reason
resolution?
And the reason that this data that we're doing has value is because the team also has their own measurements on site, so they can calibrate what the model predicts with what they're actually seeing on the on-premise measurements. And that if they didn't have that, of course, it would give an indication, but you really have to calibrate with such high resolution modeling towards the track to get something out of it. I mean, we all know that weather forecast has limitations and advantages, right? But by calibrating with an on-site meter, like measuring temperature and wind speeds and ambient temperature and so forth, then it actually has a lot of value. The granularity is still a bit limited with a forecasting model, but on the other hand, you can predict something that you would basically just be guessing. I mean, if you didn't have the forecast.
Any comments from your side on this experience, Alex?
Yeah, so we started this partnership, and sometimes in the sports market industry, there's partnerships just to add marketing value and put something on paper, nice and shiny. But we figured out this is really bringing us performance. And even if Thomas says the granularity is limited, it is still sufficient to make a difference on our end. And obviously, we add local measurements to the data set, which then refines the granularity, and we actually achieve a good outcome. Yeah.
Are we still using spotters, or is it that we are more sophisticated data collection these days? Is someone just putting the hand out?
Yeah, you actually like the safety belt. So you would do whatever is required to win a race. And this sometimes includes spotters, yeah.
Every race is different in Formula E. That's one of the beautiful things about it, right? In terms of the setup of the layout of the track. How does it work kind of as you approach the weekends that you have different phenomena meteorologically occurring, of course, as well around the world? And maybe I'll ask it this first to you, Alex, and then to get your perspective. Because of course, Saudi is very, very different from Mexico or Rome in terms of how the weather dynamics would behave and the impact they have on your temperatures, on your weather expectations, rain, wet, dry conditions, all of it.
Yeah, it's amazing how great the impact of weather conditions and obviously the location is. You just mentioned if you're in Saudi, the surface of the track will be quite sandy, dusty, so you have a different track evolution. In the same time, high global radiation. Sometimes you have an element of smog. Then you go to Mexico, high altitude, completely different story. Then you go somewhere else close to the sea, where the conditions can change at any time. It can start raining. So the challenge is always different, which makes it quite interesting. So we are not pulling out like the standard sheet with Thomas, but it's always something different to look after, always a different challenge to tackle, always different question marks, so which makes it quite interesting.
Is it from your perspective, Thomas? Do you see a model calibration significantly changing, or is it the one bullet fits all?
Well, it's the same standard model we're using, so you can say the devil's in the detail of how you calibrate it according to what you record on the track. And a place like Saudi Arabia, where you mostly have clear skies, you would see maybe in the evening like drastic temperature drops after the sun has been setting, and if the model can maybe to some extent capture that, but if it's going a bit faster in real life than the model is capturing, like by running the model a few days in advance, you will harness some of that knowledge and be more in control. But in theory, it's the same setup. We have in Vestas, we're a global brand. We're using our weather models and weather capabilities all over the place. So basically, we just change the coordinates of the model that we're running, and we spin it up on our supercomputer. So we can move the setup to anywhere in like a matter of minutes. So we can run a new model in some other location. So it is a very standardized setup that we're using.
And then how does it work? Do you get a lot of last minute requests from Alex in terms of the race prep, or is it more around the build up towards the race and collecting the models? And
I would say it's been very steady for the last, in the beginning, we kind of had to establish how to do this, or can we extend the horizon of the forecast. Today we spun up one of the models which has a shorter horizon, but is more precise. But since the race is later on, it's also nice to have like a further, you can say, horizon to the weather forecasting model. And then we're adding this as we speak, basically. And that helps already now starting to prepare what's coming at us towards the weekend.
We now have access to amazing resource with Vestas and Thomas and amazing knowledge and a big database. So we went the route of saying, well, this is something we couldn't do our own. A lot of people in motorsport feel, okay, I'm quite good in engineering, so I can solve the problem on my own. We say, well, there's experts and there's this greater resource to leverage in a good partnership. So that's the first bit. And the second bit is we don't write so many emails back and forth because we have gone the route of, okay, let's expand the digital environment and ecosystem. So Thomas is running and his team are running the models. We are pulling the information. It's integrated in our tool chain. So it's just it's a seamless integration eventually. If there's questions, it is detailed questions, but normally the model plays. Thomas and the team are doing a good job. We pull the information, integrate into our data sets and analysis and algorithms, and then we are actually good prepared for the weekend to come.
We're also providing 20 years of backlog of hourly data values from what we call the Vestas Climate Library. That's also what we're using in the siting, processing, and a ton of other assessments. So you can also have an idea of what was happening like this weekend in the first weekend of April for the past 20 years. So that means you can prepare. It's basically the same kind of data. So you would also have a really good idea before you arrive to the site what's most likely going to happen, right? So that's also some of the data I think, Alex, you and the team are using. We've been doing that for all the various locations. We've been extracting these 20 years of data from our global database, which we've been maintaining in-house ourselves.
Yeah, one prime example is Mercedes have joined Formula E in season 6, but obviously there were 5 seasons before we actually joined as a manufacturer and team. So we have access to some of the historical data, such as lap times, but obviously we don't have any weather documentation, which is the important bit of linking and merging different data sets. And this is now where the power of the historical database comes into play. We can suddenly pull the information that we have from the racing series and merge them with the Vestas historical data.
And how do you see, maybe this is more for you, Thomas, but how do you see climate change? As of course, this is one of the prime elements.
Yeah.
Is it deriving? Is it messing up with your models? Or are we still be able to?
The models that we're using are like physical models where we're actually doing measurements. Like it's a global network of measurements and remote sensing from satellites, and then you would like run break down physical equations so we would know what would be happening in the future. So the weather models are just becoming better and better. So they're not directly impacted by climate change, but I think what's occurring in the various locations where you have like the extremes of the seasons are high. You have like wetter seasons, you have drier seasons, it's hotter in the summer and so forth. I think that's more impacting directly on site, right? You might experience a weather phenomenon that's not resolved in the previous, you can say, in the historical data necessarily. But I would see as such, it's not something I see as an impact directly to what we're doing right here. But I mean, maybe Alex and the teams are seeing something like higher temperatures in Saudi Arabia during the daytime, something like that. I would say that's most likely what you'll be seeing in terms of
Or of an outlier.
Yeah, but we're trying to project for the race forecast that we're pulling some of the IPCC data and projecting climate changes into the future. But it's something we have to be a bit careful about, right? Because we have a ton of different models with a ton of different outputs, but all of them have the same trend, right? We're going to go towards higher extremes in terms of temperatures and changes in the wind and precipitation.
Alex, how does it work with you? So we gather all these data, and then I guess you're not idling in the weeks leading up to a Formula E race. So you're gathering up, and I assume you'd prepare a few scenarios, and then race weekend hits, and it becomes the stress levels go up to maximum. How do you accommodate change? This is also something that we discussed with Nick on the previous podcast, right? That you prepare for the best, but you always have those scenarios, and you have adaptability being one of the key elements, especially in Formula E with the fantastic dynamics that we see in it, right? And in terms of ever-changing dynamics between qualifying, race, and also the weather impact. How does it work for you? You prepare scenarios, and then race day you just sit at the edge of your seat with backup scenarios, or?
So stress levels is something you have to learn, you have to manage. And obviously with experience, you remain more calm. There is peaks, I must admit, but in general, I'd like to compare with a pilot. You don't go in a plane and steer a plane without knowing what's going on. You don't figure out how to fly the plane whilst you're in the air. So this is something we obviously have in our culture, in our DNA, is to do the homework, to do the preparation before the weekend. And the weekend is, again, it magnifies the challenges of the industry. You are process driven. Everything is actually built into processes. You follow processes. If something deviates, you pick a different process, and then obviously you refine your data set, you refine your plan. But normally, in most cases, if things go according to plan and your preparation is good, then the outcome is good. But then there is sometimes there is little surprises and excitement, I must admit. But yeah, overall, over time, experience, you can manage like the stress level pretty well.
And I guess also in terms of strategy, then you just adapt to the circumstances in the ever-changing environments.
So normally you have your scenarios and probabilities and risk levels defined before the weekend. Then you decide for a route and you normally stick to your route. You don't deviate. As soon as you start deviating and making decisions based on incomplete information, then it's getting more difficult and more dangerous, because then you suddenly lose actually control of the outcome. As soon as you are steering the ship, it's actually fine. Yeah.
I think that's a really good analogy, and then one that we can certainly bring back to decision making in our world, right? That it's always better to have a well-prepared plan and stick to it than starting to make too many changes. Yeah. And maybe on that note, it has been my experience starting my career in as a race design engineer that I'm still 20 years later throwing a lot of learnings from the racing world into my work today. Thomas, is there anything that we are learning? So I think it's been clear a lot of the good things that our collaboration towards the Mercedes EQ Formula E team is bringing. Are we taking any learnings that you didn't expect back home?
Yeah, I would say like we're trying to adopt some of like looking very much into the detail of what to do when. Right now we're looking at future, like in the future we'll be building plants that has to very quickly change from, depending on the energy price, if we're gonna, stop the turbines or the solar photovoltaic panels are going to produce enough, or we're then going to stop it all and start producing hydrogen for power to X. So these quick decision making actually uses the weather models in a different way, and much more like Alex and the team are doing on premises. So definitely I can see some links there, right? So technology wise we're all heading for a very interesting future, but we have to use it clever.
And I think that this is maybe one very specific question, Alex. When we talk about the sensitivities to climates now, so you mentioned temperature a bunch of times in our talk so far, being one of the key elements. Is it more relevant than rain at this point in Formula E when you're planning ahead for a race, or is rain still a driving element in terms of how you accommodate the driver in the setup of the car?
So the first question, if we walk the iteration steps of a race weekend, and the plannings are, is it going to be a dry or wet weekend? And normally, because of the race calendar and where the locations are picked for the time in the year, we normally face dry conditions. So the dominant question overall and on average across the season is about ambient temperatures, humidity, and all the factors for dry conditions. Yeah.
And I assume you're familiar with the Vestas race predictor. I don't know if you've played, as I assume you'd have a competitive advantage on it.
Yeah, it should be unfair if I played. So I had a look several times, and I was looking on the predictions and then watching over the shoulders of my colleagues playing it. It's a nice game, and effectively it's a good focus on actually what is required. And it's a light version of what we actually do on a race weekend. Yeah.
The KPIs you mentioned before, right?
Yes.
How about you, Thomas?
I'm helping provide some of the data, so it would not be fair if I started to interfere with that. But it's a nice tool, and I know a lot of my colleagues are enjoying playing that, and they always come and ping me and ask if I can, help them out a bit. But that would be cheating.
So aside from weather, what are the other elements when you in a sport like Formula E where your car setup is more or less, or the car design is more or less fixed? What are the other aspects that you dig into when you're defining your strategy? I think you've mentioned them briefly in the beginning. But
competitive advantage in Formula E you achieve through software in particular. So whilst there is less freedom on the hardware parts of the car, software is actually making a difference. And software concerns everything. Software concerns the information dash which the driver sees on his steering wheel, concerns the battery and energy management, concerns the engine motor control. So literally everything, and braking system is software based. So this is one of the biggest performance items in the car, and it's hugely complex. And you can't just join Formula E and develop software and be a competitive team. So this takes years years in time and a lot of clever people. Simulation is another one, because I explained there's always different circuits. Something is always different. So you can't rely on the historical data of the circuit, but you have to simulate the upcoming weekend. The better your simulation models are, the more accurate your preparation. Then another competitive advantage is literally any data source you can pull in any form of data, including weather information. So that's the key aspects of Formula E and how you generate a competitive advantage.
And how close are the drivers to the data that you're collecting? Are they coming and checking up on you frequently, or is it the less dynamic dialogue?
So two aspects. First of all, drivers, they check in frequently. They get a lot of updates, a lot of education before the weekend. And that's part of doing your homework, is actually educating your drivers, setting expectations and making sure they understand what the expectations and the challenges of the upcoming weekends are. And secondly, because in our simulations and software we model drivers, sometimes I wish there was no human being in the car doing something different than what we feel is the best or the most optimal.
And then maybe on that note, do you, I guess you also, that as a result of that, you end up defining different strategies for each driver, right? Accounting for their driving styles or behavior.
Yeah, similar to different weather conditions and historical data sets and databases, we have databases focusing on different elements of the driver, overtaking capabilities, their accident probabilities, for example, their starting performance, how energy efficient they can drive, the general speed in a qualifying, the general speed in a race, and so on and so forth. Yeah.
Effectively, you're trying to remove the human factor out of the humans and then model them as quickly as possible.
But that's the most difficult bit of everything.
Yes, exactly. But that's also the passion about racing, right? Is that you still have someone pushing.
You can make a difference as a human being. Everything is process driven, as I explained, and data driven, but there is a little element like 2 to 5% you can actually gain through human performance, sometimes even more. Yeah.
And of course, for us as engineers, it's the competition on the technology that we really care about. But I think that's the cherry on the top that you mentioned, right? Is that extra element that comes from the drivers. And I think that's what makes racing so interesting. Fantastic. So what are the expectations for the rest of the season, Alex? Are you confident on what we can achieve?
Yeah, we are pretty confident. We are coming in as a champion, which is evidence enough that we are actually doing a good enough job in Formula E, because it's so competitive. You never know. It's always a surprise, and different factors can catch you by surprise. But yeah, if you're sorted, if you're data driven, if your processes are good and our processes are good, then on average you will come out on top. And this is what we believe in. So going forwards, we live up to high expectations. So we do just everything to make sure we can win again and can go for the title again.
Is there a race that you're specifically looking forward to from a technical point of view or even from an enjoyment point of view?
It's literally every circuit, because every circuit is special. So it's always a challenge, and this is actually what drives us, having challenges, and there is no standard in Formula E. That's why everything is cool. Monaco is cool, obviously, for the surroundings. Rome is cool because it's a super crazy street circuit and most challenging. We are going to see new venues with Jakarta, London, where half of the circuit is actually inside a venue and half of the circuit is outside, which is another challenge for weather predictions, obviously. Yeah. Last year we had wet conditions in London, which meant outside was full wet, inside we were driving in dry conditions. So you have to make your call on car setup and have to make your decisions accordingly. Yeah.
How about you, Thomas? Is there a race that you're looking forward to for any specific reason?
Well, I would like to actually see a race like on site instead of just looking at my television screen. So hopefully I can join maybe in Berlin or something, but I that's not decided yet. But that would be the one I would be looking the most forward to. Yeah.
That would make two of us. Thank you so much, guys. This was a real pleasure to talk to both of you. Likewise. And to get to know you. So thank you.